13.6, we're going to learn about solving exponential and logarithmic equations. Today, we're only going to do exponential, and then when we come back on Monday, we'll talk about logarithmic equations. Really? Huh, it's news to me. There's class on Monday. I will be here Monday. If you're not, that's for sure. But I will be here. On Monday? No, on the Halloween, it's not Monday. All right, so there's an equation.
Yeah.
That equation is definitely not an exponential equation, nor is it a logarithmic equation.
Well, I mean, x equals 2.
What kind of equation is that?
It's a linear.
It's a linear equation. All right. I know at this point you can look at this and you can probably say the answer is 2 and you can do it in your head.
Yeah.
How do you solve that equation?
Minus 5 divided by 2.
You subtract 5 on both sides. Why do you subtract 5 on both sides? Okay. Our goal is to get the XL by itself, but why do we subtract 5?
Well, I mean, it's easier than subtracting 9.
Would subtracting 9 on both sides be wrong?
No.
No, so why did you tell me subtract 5?
Because it's a faster way to write the answer.
Well, the rule is to get x alone, and then you subtract 5. And it's one step closer to the answer.
Why?
Because it's easier.
And you can isolate the x on one side of the equal sign.
All right, so here's the words I'm looking for. What's the opposite of adding 5?
Subtract.
Subtracting 5. So to get the XL by itself, if we have an add 5, we do the inverse of add 5. The inverse of add 5 is subtract 5. 2x equals 4. And then what do you do? Why do you divide by 2?
Because what you cancel.
It's the opposite of the
Multiplication.
Because right now we're multiplying
It's not the opposite, it's
the inverse, right, because opposite means pluses and minuses. The inverse of multiply is divide. All right, so we divide by 2, and we get x equals 2. All right, how about if I gave you x squared equals 16? How do you get the XL by itself?
Take the square root.
Why do you take the square root?
Because it's the inverse of the exponent.
Because it's the inverse of squaring. The inverse of squaring is square roots. All right, so we would do square root on both sides, and you would write x equals 4. And the mean teacher would only give you half credit because you got to remember there's a plus or a minus when you do square roots on both sides. All right, so here's an exponential equation. 5 to the x equals 12. How do you get the XL by itself?
Could be log base 5. Log 5.
What's the inverse of an exponential? The inverse of an exponential is logarithm. So just like here, to get rid of a plus 5, we do a minus 5 because they're inverses. To get rid of a times 2, we do a divide by 2. To get rid of a square, we do a square root. To get rid of an exponential, we do a logarithm. So, one correct answer is, I could use the b to the y equals, this is bad because this x is different from that x, but this is the way we've typically written it. This is the same as y equals log base b of x. So in this case, we would have x is the thing that's up in the exponent, is log base 5 of 12. That's a correct answer, but not a very satisfying answer. The reason it's not very satisfying to me is, how much is log base 5 of 12? Is it close to 2 or is it close to 15? It's probably more than 1. Is it more than 2?
No, it's like 2 points.
So it is more than 2.
No,
You said 2 point something, that's more than 2.
but it's not.
Try the calculator. I looked, my calculator does not have a log base 5 button.
Well, then let's convert it.
So we convert it. All right. So we're going to convert it common log or natural log? Natural. ln 12 over ln 5. So I could use my calculator and get a nice approximation. ln 12 divided by ln 5. It's about 1.54. rounding to 2 decimal places. All right, so here's typically what we do. If we have 5 to the x equals 12, we could convert it to logarithmic form using our old definition for logarithm. Typically, that's not what we do. Typically, what we do is we take this equation and we whack it on both sides with either ln or log. We almost always use ln or log because we have those buttons on our calculator. What good does that do me? What can I do on the left-hand side with ln of 5 to the x? I can't plug it into my calculator because it's got an x right there. That's true, but what does that x button do? It's not... Oh, it'll give me an answer, I agree. But it's not the answer I want. What do logarithms do to exponents? They don't cancel them out, they bring them down front. So I do logarithm on both sides to use the property that logarithms bring exponents down. And now how do I get that x all by itself? Divide by ln 5. So x is ln 12 divided by ln 5, which is exactly the same answer we got before. Questions on that? No. But typically it's done this way because in order to get an approximation, you're going to need to convert to an ln or an log anyway. So typically we do it the second way, but either way is correct, and either way we'll get full credit. All right, let's do some easy ones. Two to the x equals 8.
Which way do you want us to do it?
I want you to tell me the answer. Why is x 3?
Well, I mean, 2 to the power of 3 is
Because 2 cubed is 8. Do you need any fancy logarithms for that one? No, you don't need any fancy logarithms for that one. That one you should just be able to look at and tell me x is 3. You shouldn't need any fancy stuff there. How about if I gave you 3 to the x is 1/9? Why -2? Because a negative exponent will square the number and drop it to the bottom. All right, so x equals -2. How about if I gave you 1/2 to the x plus 1 equals 4? It's a little harder. -1. How'd you get -1?
Because it's 2 plus 1.
But order of operations says if I plug a -1 in here, I would do -1 plus 1, which would be 0. And 1/2 of the 0 would be 1, and 1 doesn't equal 4. And how would you do that?
Or you just write it in the pocket.
Now, here's what I would do. I would write this as 1/2 raised to the x plus 1 equals how can I write 4 using a base of 1/2? -2. Why -2? Because the negative, since it's a fraction, it brings the thing up to the top. And 2 squared is 4. So sometimes this is what you want to do. Sometimes, if you can make the base on the left be the same as the base on the right, then what has to happen to the exponents? If the bases are equal, the exponents have to be equal. So x plus 1 has to equal -2, which means x should have been -3. All right, let's do one more of those. What if I gave you, I don't know, 7 is too big.
7.
9 to the
You just said 7 was too big.
to the 2x. I know, and then I went to 9. 9 to the 2x equals 81 to the x plus 1. Can I make it so that these have the same base? Over here I got a 9, over here I've got an 81. Can I make them the same? Because 81 happens to be 9 squared. So I can take this and write it as 9 to the 2x equals 9 squared to the x plus 1. And then on the right hand side, what happens? Oh, I gave you a bad problem. We're going to see why in a minute. What happens when you have a base to a power followed by yet another power? You multiply those powers, don't you? So this is going to be 9 to the 2x plus 2. So now that the bases are the same, what has to happen with the powers? The powers have to be the same. So 2x plus 2 has to equal 2x. And this is what happens sometimes when you make up problems off the top of your head.
Yeah, man.
Subtract the 2x, we get 0 equals 2.
Yeah.
When does 0 equal 2?
Never.
Never, which tells you what about this equation?
It's undefined.
If the equation is not undefined,
No.
the equation has no solution. Parallel is an interesting word there. Parallel is usually reserved for lines. If you graph these, are they lines? No, but you've got the right idea. They're the curves, and they really are parallel. But usually we don't talk about parallel curves. We only talk about parallel lines.
It's the same.
But you're really right. These are parallel. The correct answer would be no solution. All right, so that happens once in a while when you make up problems off the top of your head. Now, most of the problems we're going to deal with in this section, the bases will not be the same. I might give you something like 5 to the x plus 1 equals 8. Is there any way you can turn an 8 into something with a base 5?
No. Yes.
Yes, you can, but not using nice numbers.
Right.
Yes. You'd have to use some sort of ugly, irrational number. So what we're going to do in this case is we're typically going to take this equation and we're going to whack it on both sides with a logarithm. Which logarithm do you want to use? ln. All right, so I would use ln 5 to the x plus 1 equals ln of 8. And why do we whack it with a logarithm? Because the exponent can move down. So this becomes x plus 1 times ln 5 equals ln 8. And then what fancy math do I do to get the x all by itself? Divide. So x plus 1 is ln 8 over ln 5. And then finally, minus 1. So x is ln 8 over ln 5 minus 1. And if I wanted to, I could use my calculator to get an approximation of that. ln 8 divided by ln 5 minus 1 is not 2. It's more like about 0.29. I had a 2 in it. I'll concede that. All right, how about if I gave you... Oh, let's go back to something else, something you already know. What if I gave you 5x squared minus 9 equals 11? How would you get the x all by itself? Add the 9. 5x squared equals 20. Divide by 5. X squared is 4. And then take the square root. X is plus or minus 2. All right, so notice what you did. You wanted to do a square root because you saw a square, right? But before you could do the square root thing, what did you have to do? You had to get the x squared thing alone before you could do square root. The same thing happens with exponential functions. If I gave you 3 times 2 to the x minus 4 equals 5, you see that you have exponential right here. So what you want to do is you want to do logarithm. Before you can do logarithm, you need to get this piece all by itself first. Just like up here, before we could do square root, we had to get that piece all by itself first. So how would you get that piece all by itself? Add the 4. So 3 times 2 to the x is 9. Divide by 3, 2 to the x is 3. And now you can do logarithm. Just to be different, I'm going to use common log this time. Log of 2 to the x equals log 3. Common log has the exact same property with exponents. What does common log do with exponents? Brings it down. X log 2 equals log 3. So x is log 3 over log 2. And again, if I wanted to, I could use my calculator. Get an approximation. 1.58. You're fairly close that time. Questions about solving exponential equations? Give us something really hard. We learned how to solve exponential equations. And how did we solve exponential equations?
Like getting a number with the exponent.
Okay. We got the exponential piece alone. So if we had something like 5 times 4 to the x equals 30, we got the 4 to the x alone first.
You check out the logarithm.
And then you attack it with a logarithm. And the truth is you can use any logarithm you want. We chose to always use log or ln because we have buttons on our calculator. The point is, you get the exponential piece alone, and then you do the inverse of an exponential. The inverse of an exponential is a logarithm. So we would write x ln 4 equals ln 6. So x is ln 6 over ln 4. So, how do you solve a logarithmic equation? First, you want to get the log all by itself. It's all by itself. And then what do? How do you get rid of an log? You use its inverse, and its inverse is exponential form. All right, so we take this and we convert it to exponential form. Exponential form would be base, which is 3, to the answer, which is 9, equals x. From there, I guess we could grab our calculator. 3 to the 9th, that's a pretty big number. So x is 19683. 19,683. All right, but that's going to be the basic technique. The basic technique is going to be get the log by itself and then use its inverse, which is exponential. All right, so what if I gave you log base 2 of x minus log base 2 of, 5 equals -3. Almost. What would you do?
Well, log.
Right. Notice we have 2 logs. I need to write it so that I only have 1 log. And remember a couple sections ago we learned how to take several logs and combine them. So we would rewrite this. Logarithms take subtraction on the outside and turn it into division. So if you have more than one log, you need to combine them together using those rules we had the other day. What's that? As long as they have the same base. They will have the same base in this section. No way around it. We don't know how to solve logarithm equations that have different bases. Yeah. All right. Once we have one single logarithm, we convert it to exponential form. So again, to exponential form, we have the base, which is 2, raised to the answer, which is -3, is the thing inside. The thing inside in this case is x over 5. How much is 2 to the -3? 1/8. So this is the same as 1/8 equals x over 5. How would you get the x all by itself? Multiply by 5. So x is 5/8. Questions on that one? All right, how about log base 2 of x plus log base 2 of, I gotta try to be clever to make this come out. I probably won't be right. X minus 2 equals 3. X minus 2 net. Same sort of deal. We see that we have more than one logarithm. When we have more than one logarithm, we have to combine them together. In this case, since we're adding, it becomes multiply. Convert 2 cubed equals, I'm going to write this over here as x squared minus 2x. It's going to distribute that x through. So 8 equals x squared minus 2x. And how would you solve?
Yeah.
Well, if I factor out x, then it's just back to the x times x minus 2. You're close. You want to factor, but you got to do something before you factor. You got to have 0 on one side in order to be able to factor. That's correct. So 0 equals x squared minus 2x minus 8. You always have to have 0 on one side before you can factor. Does it factor? It factors as x minus 4 and x plus 2. So I get two answers. I get x equals 4 and x equals -2. One of those two answers is correct, and one of them is wrong, and you say the 4 is the correct one and the -2 is the wrong one?
Yeah.
What's wrong with -2? It is the -2 that's the problem. What's wrong with -2?
So now you can't have a negative number.
What kind of numbers can I plug into logarithm? The only kind of numbers I can plug into logarithm are positive numbers. Can I take -2 and plug it in right there? No. Can I take -2 and plug it in over there? No. Can I take 4 and plug it in right there?
Yeah.
Can I take 4 and plug it in right there? Yes, because I would get 4 minus 2, which would still be positive. If this turned out to be x equals 1, I would have to throw that one away too, because 1 minus 2 would be -1. I can't do a log of -1. So when you solve these, you do need to make sure that you get numbers that are within the domain. In other words, you need to make sure you always get positive answers. You're not going to be able to have negative answers here. Questions on that? All right, what if I gave you a couple more? ln. Oh, let's do this again. 3 ln x minus ln of 7 equals 6. All right. How would you solve that equation?
ln.
All right, so same deal. First off, we have to write it as a single logarithm. So you did 2 to 1 there. This 3 goes inside, and when it goes inside, it becomes an exponent. And then the minus tells us to divide. All right. Correct. You got to remember when you're using ln, your base is e. So you're going to have e to the 6th equals x cubed over 7. How do you get that x all by itself? Multiplied by 7. So x cubed equals 7e to the 6th. What's the opposite of a cube? Cube root. Just like the opposite of a square is a square root, the opposite of a cube is a cube root. So the answer would be x is the cube root of 7e to the 6th. There's a nice answer, huh?
Yeah.
Perfect. You come out with a nice number?
Yeah.
That I highly doubt.
Oh, yeah.
Math. Cube root 7e to the 6th. It's about 14.13.
Yes.
All right. I'm glad you